Hello, and welcome to this presentation, Getting Started with the CMA180 Basic Transmitter Testing. In this presentation, we'll provide a short explanation of how to perform basic transmitter testing of two-way radios using a Rohde Schwarz CMA180 radio test set. This presentation only covers how to test the transmit portion of a two-way radio. Please see the separate presentation, Getting Started with the CMA180 Basic Receiver Testing, if you'd like a similar explanation on how to test the receive portion of a radio. There are two steps in testing two-way radio transmitters with the CMA180. Basic functionality is tested by having the radio under test transmit into the CMA, and then measuring the characteristics of the RF signal, such as frequency and power. An additional step involves having the CMA perform audio quality measurements. In this case, the CMA provides the DUT with the audio frequency signal used to modulate the carrier, usually a simple 1000 Hz tone. After demodulating the received RF and extracting the audio, traditional audio measurements such as total harmonic distortion, signal-to-noise ratio, etc., are performed on the CMA. In this presentation, we'll go through both of these types of tests, beginning with basic functionality testing. For our test setup, we'll connect the CMA180 to the radio under test by removing the antenna, and then connecting a cable between the CMA's RF COM connector and the radio's antenna connector. We'll then cause the radio to transmit a signal to the CMA180. This can be done in several ways, the simplest of which is pressing the radio's PTT or push-to-talk switch. Many radios also have a way to connect an external PTT switch to activate PTT. And finally, some radios can also be configured to transmit when audio is received. This is often referred to as a VOX, or voice-activated transmission. Before we go on, let's pause for a moment to discuss RF input connections and levels. The CMA180 has two ports that can be used for measuring the RF output of a DUT, namely RF COM and RF in. These ports do, however, have very different maximum input power levels. For RF COM, the maximum input power is 100 watts continuous and up to 150 watts maximum. Whereas for RF in, the maximum input power is only plus 20 dBm, or 100 milliwatts. Since the RF output power of most two-way radios is on the order of single-digit watts or more, RF COM is the recommended input port, since in almost all cases, it allows the radio output to be directly connected to the CMA180 without risk of instrument damage. If RF in were used, then significant external attenuation, in most cases at least 20 dB, would be needed to protect the input from damage. To run a transmitter test on the CMA180, we start by going to the global toolbar and then selecting TX, that is transmit, under the Analog tab, since we're testing the transmit portion of the radio. The TX test main screen can be divided into two areas. On the right are the analysis functions, which we can use to measure both the RF and the demodulated AF signals from the radio under test. On the left side of the screen are the generator controls. In the second step of our test scenario, we'll configure the generator to create an audio signal that will be used as the modulating input for the radio under test. For basic transmit functionality testing, we'll look at the results under two analysis tabs, the RF Results tab and the FFT Spectrum tab. Note too that analysis functions are started and stopped using the play button on the right-hand side of the analysis screen. Let's first look at the RF Results tab. The RF Results tab provides a general overview of two types of measurements. The upper pane shows RF power and frequency measurements, and the lower pane shows measurements of the demodulated audio signal, if applicable. There are three common parameters that must be set to match the radio under test. The first is frequency, which should be set to the center frequency of the signal to be measured. The next is the expected power, which should be set slightly higher than the maximum expected signal power. Note that the units can be changed between dBm, watts, etc. And finally, The modulation type or mode must also be selected. For example, FM, AM, single sideband, etc. Another important tab is FFT Spectrum, which shows an FFT-based plot of power as a function of frequency, similar to what's found on a spectrum analyzer. The display is centered around a user-defined frequency, which should be set to the .transmit frequency. The x-axis of the plot shows relative distance from this frequency, by default in units of megahertz. While the DUT is transmitting, there should be a relatively narrow peak in the center of the display, with no other signals present. Although the default measurement values are appropriate for most DUTs, these can also be adjusted by clicking on the configuration icon. In addition, more precise numerical results for frequencies and levels can be obtained by using markers. Please see the separate presentation, Getting Started with a CMA180 FFT Spectrum, to learn more about how to configure and interpret FFT spectrum measurements. Next, let's look at analyzing demodulated audio. Our test setup for audio analysis is the same as for basic transmit testing, except that we will configure the CMA's generator to source an audio signal that will be used as the modulation source for the device under test. The RF signal modulated by this audio signal will be demodulated by the CMA180, and the recovered audio will then be analyzed. Although most radios have some kind of jack or port which can be used for audio input, it may be necessary to wire an appropriate cable to connect this input to the BNC connector on the CMA180. Let's start with generator configuration. In the transmit test scenario, the generator type is automatically set to audio frequency, with output enabled. The most important DUT-specific configuration parameter is the AF level, which must be set appropriately for the given DUT. Most two-way radios expect an audio input signal level on the order of tens or hundreds of millivolts. For basic transmitter testing with audio demodulation, the remaining settings can usually be left at their default values, namely source set to generator 1, mode set to single tone, and frequency set to 1000 Hz. With these settings, the signal at the AF1 output connector on the CMA will be a 1000 Hz tone with the user-specified voltage level. We'll assume that we're using the same RF settings as before, that is, the same frequency, expected power, and modulation type. In this case, we simply need to start both the generator and the analyzer. At this point, if we enable the CMA's built-in speaker, we should hear the demodulated audio signal received from the radio under test, in this case a 1000 Hz tone. Once we've verified that audio is being received, we can next analyze this audio signal. This is the main analyzer screen, which shows measurements made on the demodulated audio from the radio under test. The results are divided into tabs, with the Overview tab providing a summary of the most important measurements and views. The AF Results tab provides more detailed numerical results, and the AF Spectrum tab shows level graphically as a function of frequency. Let's take a brief look at each of these last two tabs in a bit more detail. The AF Results tab displays numerical values for several different audio quality measurements, such as total harmonic distortion, SINAD, and signal-to-noise ratio. Note that these measurements require that the RF input signal be modulated by a single frequency tone, which by default is a tone with a frequency of 1000 Hz. Different frequency tones can, however, be used, and the frequency of both the generated and analyzed tone can be automatically coupled together by going to the AF Settings tab under Analyzer Configuration. The AF Spectrum tab shows amplitude as a function of frequency, and this can be useful when examining the received audio signal for harmonics, distortion, noise, etc. The small configuration icon can be used to change the frequency span and/or to select a different type of FFT window if needed. Let's end with a brief summary. The Rohde Schwarz CMA180 radio test set can be used to perform both transmit and receive testing on analog two-way radios, And in this presentation, we've walked through how to test the transmitter portion of a radio. For this type of testing, the CMA measures the RF signal received from the DUT and provides both numerical values of RF power and frequency, as well as a graphical spectral view. An additional testing step involves modulating the radio's output using an AF signal sourced by the CMA. This is usually a 1000 Hz tone. The CMA can then demodulate this audio from the received RF carrier and perform traditional audio measurements, such as total harmonic distortion and synad, as well as display a spectral view of the audio signal. This concludes our presentation, getting started with the CMA180 basic transmitter testing. If you'd like to learn more about radio test or radio testing with the CMA180, please see the links in the video description. Thanks for watching. Please subscribe to our YouTube channel and visit us at Rohde-Schwarz.com.